All right, let's jump right in. What if our most powerful AI models, the ones that are completely changing our world, are suffering from a massive, fundamental flaw? A kind of digital amnesia that stops them from ever truly learning anything new after they're built. Today, we're going to explore a pretty radical new idea from Google Research that might just give AI a memory.
So, to really get why this new idea is such a big deal, we first have to understand the problem. And trust me, it's a big one. Our most advanced AI, for all of its incredible power, has this critical limitation just baked right into its design. It's a limitation that makes it fundamentally different from the most powerful learning machine we know of.
And that learning machine is, of course, our own brain. Our brains are just defined by this thing scientists call neuroplasticity. This absolutely incredible ability to reorganize, to form new connections, and to just learn continuously from every single new experience. We are constantly updating our own software every single day.
But large language models, LLMs, they just don't work that way at all. Once that massive training phase is done, their knowledge is basically frozen in time. They can't really acquire new, permanent knowledge from our chats or from any new information they see. They are, as these researchers put it, largely static.
The researchers use this powerful and honestly perfect analogy for this condition: anterograde amnesia. It's a real neurological disorder where a person can remember their past, but they can't form any new long-term memories. Every new experience just fades away. Sound familiar? That's an LLM. It remembers its training data, its long past, and it can handle the immediate short-term conversation in its context window. But anything new, it never ever gets consolidated into long-term knowledge.
When you see it laid out like this, side by side, the difference is just stark. The human brain is in this constant state of continual learning, always forming new memories through really complex processes. But current LLMs, they are fundamentally static. Their memory is totally limited to what's right there in the immediate conversation. And once that context is gone, so is the memory. Their knowledge is frozen solid the second that training is over.
Okay, so if we want to fix AI's amnesia problem, where do we even look for inspiration? Well, we go right back to where we started, the brain. Turns out the secret isn't just that the brain learns, but how it processes information at completely different speeds. And this right here, this is the brain's secret weapon. It's a multi-speed processing system. It uses all these different brain waves, or frequencies. You've got super fast gamma waves processing what you're seeing and hearing right now, while really slow delta waves are associated with deep sleep and locking in memories. It's not one single clock. It's like a whole symphony of different rhythms all playing at once. And this isn't just some weird biological fact. It's the absolute core mechanism for how we learn. This ability to process stuff on multiple timescales at the same time is what lets us take a fleeting experience, stabilize it, and then weave it into our long-term understanding of how the world works.
And that brings us to the big idea from this Google research paper. It's a complete rethinking of how an AI model should be built from the ground up, and they call it nested learning. Okay, so instead of one giant model learning everything at one speed, nested learning imagines a system of systems. You have multiple learning processes literally nested inside each other, and each one is running at its own frequency, learning from its own type of information, just like the brain's different waves.
This diagram just illustrates the whole concept perfectly. On one side, you have the standard deep learning view, this flat one after the other sequence of layers. But the nested learning view shows you what's really going on, multiple levels of learning, each with its own gradient flow, its own pathway for updates, all happening at the same time.
And this quote just nails it. This is the key takeaway. The paper is arguing that the next huge leap in AI isn't going to come from just adding more and more layers to make models deeper. No, it's going to come from stacking independent, multi-speed learning processes. Now, this is where the whole idea gets really mind-bending. Because nested learning doesn't just propose new types of models, it completely reframes how we should be looking at the ones we already have. It basically suggests that what we think of as separate parts of a model might just be an illusion.
Let's start with a really fundamental question. We use these tools called optimizers to train our models. We've always just treated them like static, dumb algorithms. But what if the optimizer itself is actually a learner?
So according to this nested learning idea, a standard optimizer with momentum, which is a super common technique, is actually a simple two-level learning system. At the first, slower level, the model's main weights are learning from the data. But at a second, much faster level, that momentum term is also learning. It's learning to compress the history of all the recent updates to better steer the main learning process. It's like a memory system for the training process itself.
And when you really lean into this idea and you design a smarter learning process for the optimizer, the results are pretty clear. Here you can see this more advanced delta momentum optimizer, in red, finding its way through a complex problem much more efficiently than the standard approach in black. It learns the terrain better because, well, it's a better learner itself. This reframing applies to the model's architecture too. We tend to think of a transformer model as having different parts, right? Like a static feed-forward network and a dynamic attention block. But nested learning argues this is just an illusion. They're actually both the same kind of structure. The only difference is the frequency at which they learn. The feed-forward network is a level 1 learner. Its knowledge is stable and persistent. The attention block is a level 2 learner. It adapts super fast in context to what you're writing. So it's not different parts, it's just different speeds.
So what's the end game here? What does all this build towards? If we can actually build AI based on this principle of nested multi-speed learning, what does that make possible?
Well, the possibilities are just transformative. We're talking about an AI that can learn new facts without needing a complete multi-million-dollar retraining session. Models that could learn a new programming language just by reading a textbook. We're even talking about systems that could improve their own internal learning algorithms over time. It would create a real spectrum of memory, from a fleeting thought to permanent knowledge, just like ours.
Ultimately, this changes the entire game. We would move away from this idea of AI as a finished product, as some kind of static tool, and instead, we could start to build true learning partners, systems that actually evolve, adapt, and grow their knowledge right alongside us. And that really leaves us with one final, pretty profound question. Once we finally cure AI of its amnesia and give it the ability to truly learn forever, what is the very first thing we should teach it?